Welcome back, fellow developers. I'm your host Don Hash, and I hope you enjoyed part 1 of our Java coding hacks series, where I delved into some essential techniques to optimize your Java code for superior performance. Now it's time to take the next leap forward with part 2. In this video, we'll be exploring 5 more incredible coding hacks that will further refine your Java applications, making them faster and more efficient. Let's continue. Point number 6. Using parallel streams for data processing. Let's explore the power of parallel streams in Java and how they can significantly boost the performance of data processing operations. In Java 8, the Stream API was introduced, providing a functional approach to work with sequences of elements. Streams enable you to perform various data processing operations such as filtering, mapping, reducing in a concise and expressive manner. When it comes to understanding parallel streams, a parallel stream is a special type of stream that allows the underlying data to be processed concurrently on multiple threads. Unlike sequential streams, where operations are performed on a single thread, parallel streams divide the data into smaller chunks and process them in parallel on multiple cores of the CPU. Parallel streams are particularly beneficial when dealing with large datasets or CPU-intensive tasks. By leveraging multiple cores, parallel streams can potentially achieve significant performance gains. To convert a sequential stream into a parallel stream, you simply call the parallel method on the stream. In the code example, I have a list of numbers and use both sequential and parallel streams to filter and print the even numbers. Keep in mind that while parallel streams can provide performance improvements, they might not always be the best choice for every situation. The decision is to use parallel streams should be made based on the size of the dataset and the nature of the operations being performed. When it comes to performance considerations, when using parallel streams, we need to consider the following performance-related aspects. Thread safety. Ensure that the operations performed in parallel are thread safe, as multiple threads will be executing them simultaneously. Statelessness. Operations within the parallel streams should be stateless and free from side effects to avoid unpredictable behavior. Load balancing. The Java runtime automatically handles load balancing across threads. However, unevenly distributed data or operations might result in suboptimal performances. Overhead. Parallel stream processing introduces some overhead due to thread coordination and data partitioning. Some small datasets or simple operations, for small datasets or simple operations, the overhead might outweigh the benefits. So, parallel streams are a powerful tool for optimizing data processing in Java, especially when dealing with large datasets and CPU-intensive tasks. By leveraging multiple threads, you can take advantage of the full processing power of modern GPUs, modern CPUs, and significantly improve the performance of your applications. However, keep in mind the performance considerations and always profile your code to ensure that using parallel streams is the right choice for your specific use case. Point number 7. Leverage static and final keywords. When it comes to optimizing your Java code, using the static and final keywords can provide significant performance benefits by enabling compiler optimizations. Declaring methods, variables, or classes as static means they belong to the class rather than an instance of the class. Static methods can be invoked without creating an object, reducing object instantiation overhead. In this piece of code, the add method in the mathUtils class is static. We can directly call it without creating an instance of mathUtils. On the other hand, using the final keyword on variables or methods indicates that their values or implementations cannot be changed, which helps the compiler perform certain optimizations. In this example, max value is a constant variable declared as final, and the compiler can treat it as a literal whenever it's used, potentially leading to performance improvements. So let the compiler optimizations work their magic for you when you are using static and final keywords. Point number 8. Employ lazy initialization. Lazy initialization is a technique where you delay the creation of objects or loading of resources until they are actually needed. This is especially useful when dealing with expensive operations such as creating complex objects or reading data from a remote server. In this example, expensive resource is loaded only when getResource is called for the first time. Subsequent calls will return the previously initialized resource, avoiding unnecessary recreation. This is same as the singleton design pattern. So delaying expensive object creation until the perfect moment will save precious time and resources, improving the performance of your application. Point number 9. Use buffered I/O. Reading or writing data to files or streams can be time consuming, especially if you perform frequent I/O operations. To minimize the overhead, it's advisable to use buffered I/O, which involves wrapping the streams with buffered counterparts like buffered reader or buffered writer. In this example, we use buffered reader and buffered writer to read and write data efficiently. These buffered streams reduce the number of actual I/O operations, leading to improved performance. Point number 10. Avoid unnecessary exception handling. Exception handling is a powerful feature in Java, allowing you to handle unexpected situations gracefully. However, using exceptions for regular flow control can be costly in terms of performance. So prefer using conditionals and proper validation to handle expected situations instead of relying on exceptions. In this example, we catch the arithmetic exception to handle the division by zero case. Instead, it's better to validate the inputs beforehand and use a conditional statement to handle the situation. So you don't have to catch for the arithmetic exception when the divisor is 0. And that wraps up our video series in 10 interesting coding hacks to boost the performance of your Java code. I hope you found these tips helpful and that they'll make a difference in your day-to-day coding project. If you have enjoyed the content, don't forget to like, subscribe and hit that bell icon to stay tuned for more exciting coding insights. Until next time, happy coding.